Hello, programmers. My name is Dan McElroy, and I am starting my own cell phone company. I'm going to get lots of customers. I already have 9. I am even his first customer. Soon, I hope to double my customer base. Then I can sell the company and get rich. I'll let AT&T, Verizon, and T-Mobile bid against each other. Then I can become a millionaire. In the meantime, I need you to help complete the billing program. It's almost done. It just needs a few more things to make it complete. Here are a list of topics in the discussion: project definition, modular program design, review of arrays, a double-dimensional array of strings, converting between string and double both ways, comparing strings, use of math.floor and math.ceil, helper functions, formatted output. There are several concepts covered in the video that may seem difficult to understand at first. If you have a problem with one section, I suggest you go back and revisit it until you can understand it. Here is the project definition. Each plan has unlimited calls and text. The price of each plan is determined by the amount of data the customer wants to purchase each month. Data usage over the purchased limit is $15 per gigabyte or any portion of a gigabyte. Plan A, $50 a month with 0 gigabytes of data included. Plan B, $60 a month with 2 gigabytes of data included. Plan C, $70 a month with 4 gigabytes included. Plan D, $90 a month with 10 gigabytes of data included. The program is to input the number of gigabytes used by each customer, compute and save in the array the amount due, bill for each customer, display a statement using a minimum of 2 lines for each customer. The statement must show the account number, plan, name, gigabytes used, and bill with 2 digits past the decimal. Display the total amount billed for all customers with 2 digits past the decimal. Customer account data is stored in a double-dimensional array with 5 fields for each customer: account number, customer name, plan, gigabytes used, bill. Your task is to complete the program to include billing for all 4 plans, display each customer's bill on 2 lines with 2 digits past the decimal, display a summary of the total billed for all customers with 2 digits past the decimal. Get a copy of Java cellphonebill.java and follow along during the discussion. You need to update and modify this program before submitting your project lab report. The code is located on the Canvas web page and at http://program-info.net/java downloads/java cellphonebill/java cellphonebill.java. The first thing the program does is display the customer's name, account number, and plan selection, and then input from the keyboard the number of gigabytes used for each customer. In this example, the first customer used 0.7 gigabytes, the next customer used 3.6 gigabytes, and so on. When all of the customer data has been entered, the program computes the bill for each customer, then outputs a report including the total of all bills. Customer Dan McElroy used 0.7 gigabytes and is on Plan A with no data included in the plan. Therefore, the bill is $50 plus an additional charge of $15 for the first gigabyte or part thereof. The second customer, Manuel Estrada, is on Plan C with 4 gigabytes included in the plan. Manuel used 3.6 gigabytes and did not go over the amount of data included in the plan. There were no additional charges, so Manuel's bill is $70. Good job, Manuel. Instead of placing all the code in one module, the program is divided logically into separate subroutines implemented as methods in Java. The first module, input gigabytes used, asked for the amount of gigabytes used in the billing for each customer. The second module, bill customers, computes the bill for each customer based on the plan they selected and the amount of data used. The third module prints out the bills for each customer. The main module is very simple. It just calls these methods one after another. In programming, the word call is used when one part of the program jumps to a subroutine or function. The subroutine or function executes its code and then returns back to the original part of the program. Each of the modules will be accessing the customer account data table, which is implemented as a double-dimensional array of strings. The array must be defined outside of all of the individual methods, functions, or subroutines to make it visible to them all. If the array were defined as part of any of the modules, then it would only be accessible within that single module. Review of arrays. Arrays store a group of values that are all the same type. Array elements are accessed by their index placed inside square brackets, which indicate their position in the array. Arrays always start the first position as index value 0. To access the first value in an array named list, use list sub 0, or list with the 0 inside the square brackets. For example, int square bracket list equals curly brace 5, 9, 2, 3, close curly brace, semicolon, declares and initializes the array. Int x equals list, open square bracket, 0, close square bracket, semicolon. This gets the data from position 0, which is a 5. The length of an array is fixed once it has been created. Int size equals list.length, semicolon. Size becomes a 4. Arrays can be created at compile time and initialized with literal values such as int list equals open curly brace 5, 9, 2, 3, close curly brace, semicolon. String array. Compass equals open curly brace. Quote, north, quote, comma, quote, south, quote, comma, quote, east, quote, comma, quote, west, quote, close curly brace, semicolon. All of the strings are in quotes. Or arrays can be created when the program is running. Int array scores equals new int 20. Creates an array of 20 integers. Arrays created at runtime are automatically initialized. Numeric arrays are initialized to the value 0. Boolean arrays to false. The programmer is responsible for writing code that does not try to access an array out of bounds. Legal values are 0 up to length -1. Here are some examples of using arrays. An integer array named scores is declared and initialized at the same time. The length property identifies the number of elements in the array. A for loop can be used to go through the array to add up all the values in the array. Once the total is known, the average can be computed by dividing the total by the number of items in the array. A for loop can also be used to loop through the array and display each element. The customer data is stored in a double-dimensional array of strings, although some of the information for gigabytes used and the bill could be stored as type double. Other pieces in the array must be stored as type string. There is a dash as one of the characters as part of the account number. The customer's name and plan selection are also made up of character strings. Since everything in an array must be the same data type, string was chosen. Later in the program, when it is necessary to make numeric calculations, the field for gigabytes used can be converted into a double for the math computation, and the numeric value for the bill will need to be converted into a string in order to be stored in the array of strings. The rows and columns could represent anything you wish in a different program, but for this program, the rows represent a record for each customer, and the columns are used as fields for each record. In Java and many other languages like C and C++, a double-dimensional array is really an array that contains other arrays. The first set of square brackets is used to hold the index for the row, and the second set of square brackets is used to hold the index for the column. If the customer base grows, then more rows will need to be added to the array. In a much fancier database program, each row would be referred to as a record, and fields can be different data types. There are 9 customers saved in this double-dimensional array. The index values for the customers goes from 0 to 8. Although in the code for the program, the fields could just be referred to by their index values, 0, 1, 2, 3, or 4. It would be much better and more professional to give each column a name, such as account, name, selection, used, and bill. Just to make this program simpler, the customer data is being declared and initialized as part of the program. In a fancier program, the data might be stored in a disk file and loaded into an array which would be created dynamically when the program runs. Look at how the double-dimensional array is declared and initialized. This array is declared outside of main and all the other methods so that it can be accessed by any of them. Since main and the other methods are declared static, the accounts array must also be declared as static. The access modifier private indicates that this array can only be accessed from within the class. Since our program only has one class, it really does not matter if the access modifier for the array or any of the other methods were public or private. However, main must be public so that the JRE can find it to start the program. Since this is a double-dimensional array, one set of curly braces are used to define the entire array, and the other sets of curly braces are used within the outer curly braces to define the data for each row. A comma is used to separate the data for each column, or field in our case, and a comma is used after the closing curly brace for each row. A final curly brace and semicolon are used when we are all done creating the array. Constants are defined using private, static, final, and capital letters are used for each field name. Now, fields can be referred to by their names such as account, name, selection, used, and bill. The name of the array is accounts. The following code would access the plan selection for Alice Brown. Int customer equal 4. String plan selection equals accounts subcustomer sub selection, where 4 is the row for Alice Brown. The input gigabytes used method is the only part of the program that is doing input from the keyboard. Therefore, the scanner object named stdin is created within input gigabytes used method. The for loop is going to step through the array, but it needs to know how many rows there are. This is accomplished with int number of customers equal accounts.length. If you wanted to know how many columns, or fields in our case, there are in row 0, use int number of fields equal accounts sub 0.length. Field count for record 0. The for loop declares an integer variable named customer that will be used as the index for the row as it goes down through the list of customers. A printf statement is used inside the for loop to identify the customer name, account number, and plan selection. Since the customer names can be different lengths, and it would be nice to have all of the text line up, the part of the printf format string for name is 15.15s, which gives a 15-character right-justified area on the screen for the name. Use a minus sign in percent minus 15.15 to make the field left justified. Only percent %s is needed in the printf format string for the account number and plan selection, since the length of the strings for these two fields are the same for all customers. After the identification for the customers displayed by the printf statement, the gigabytes used is read from the keyboard and stored in the array. Accounts subcustomer subused equal standard in dot next line. Accounts is the name of the array. Customer identifies the row. Used identifies the field. Standard in dot next line reads a string from the keyboard. The equal sign is the assignment operator, which stores the data from the keyboard into the customer's used field. The loop continues until the gigabytes used are input for all customers. This method is going to be the most complex of them all, and I am only going to give a partial solution, just enough to get you started. You get to finish the rest. Note, you will not receive full credit for the exercise if you use numeric values to select the fields within the customer record. Your program should use named constants such as account name selection used and bill to select the fields within the customer record. Look up values for the gigabyte limit and plan price based on the customer's selection. Write a separate method that does the computation of the bill to reduce the amount of duplicated code. The variables gigabytes used and bill are declared outside of the for loop. Int number of customers is used to determine the number of times to go through the loop. The variable int customer is created when the for loop is created and only exists in memory when the for loop is being executed. It disappears when the for loop ends. A clever programmer could skip declaring the int number of customers by using accounts.length in the for loop. Although Java has an enhanced for that is great for working with arrays and collection, it does not work well with multidimensional arrays. Because data stored in the arrays must all be the same data type, and the accounts array that stores the customer information is of type string, the gigabytes of data used and the amount of bill must also be stored as type string. However, when doing computations, numeric data is needed. I went to the internet because I couldn't remember the exact method of converting a string to double or double back to a string. I found several methods and chose to use double.value of string whatever. Look at the capitalization of double. Since the first letter of double is capitalized, that indicates that Java has an object-oriented programming class named double. Just place this in the back of your mind when objects are covered. This method is used to get data from the string array named accounts and convert it into a double so it can be used in math computations. String.value of double bill will convert the value of bill, which is a double data type, into a string so that it can be stored back into the array of strings. A number format exception will occur if the user entered anything other than numeric data for gigabytes during execution of the input gigabytes used method. If this exception is not processed, the program will crash when the double.valueof method tries to convert garbage into a double. Use the try-catch blocks inside the for loop to catch and process this type of problem so that the program does not crash. Although the next person looking at the program could decipher what accounts customer 2 means, the 2 is not very descriptive. It only means field 2. Account subcustomer sub 3 or account subcustomer sub 4 don't have a lot of meaning either. At the top of the program, where the accounts array is defined, also define some names for each field. Now, field 0 will be known as account. Field 1 will be known as name. Field 2 as selection, and so on. These field names can be used in the program to make it more clear of what is happening. This is much better. If accounts subcustomer subplan dot equals parentheses makes much more sense than if accounts subcustomers sub2. The for loop is used to step through the array of customer accounts. The variable customer is declared as part of the for loop's initialization and is set to 0. Each time through the loop, customer is incremented. The customer variable is going to be used as the index into the array to select a customer record. The program needs to determine which plan the customer is on. The program checks to see if the customer is on plan A. If so, then all of the code to compute the bill for plan A becomes part of the if statement. Then an else if statement checks to see if the customer is on plan B. Similar code for plan A would need to be written for plan B, but substituting anything that relates to plan A for plan B. Another else if and a block of code for plan C. And again, another else if for plan D, and more code. Collections of if, else if, and so on should have a final else clause to handle the possibility of no other matches. A Boolean true false is produced comparing numbers and characters when using the double equal. For example, character grade. I'm assuming I'm going to input a grade for when. If grade equal, quote, W, system.out.println. Great job. However, strings in Java are objects, not primitive data types like int, double, character, or Boolean. When using double equal with objects, Java checks to see if the objects on both sides of the double equal are the same object in the same memory location, not if their contents are the same. Using double equal with objects is only good if you have two references and you want to see if both references are for the same object. We will see more about this in the discussion of objects. Use the dot equals string method to see if the contents of two different strings are the same. For example, string plan equals, quote, plan dash A, quote, semicolon, or plan could be read from the keyboard. Compare the contents of string plan to the string literal, quote, plan dash A, quote. System.out.println. It is plan A, else system.out.println. Try another plan. Here is a brief description of what happens with positive numbers when using math.floor, math.ceiling, and math.round. Read the documentation from oracle.com for a fuller description of what happens when working with negative numbers. Although each of these methods returns a double data type, the value returned is a whole number. Math.floor returns the next lowest integer value if there are places past the decimal. Math.floor 1.0 returns a 1.0. Math.floor 1.3 and Math.floor 1.99999 also return 1.0. Math.ceiling returns the next highest integer value if there are places past the decimal. Math.ceiling 1.0 returns a 1.0. Math.ceiling 1.3 and Math.ceiling 1.99999 return the next highest integer value, which would be 2.0. Math.round rounds down or up to the lower or higher integer value. Since the definition for the cell phone bill project states data usage over the purchased limit is $15 per gigabyte or any portion of a gigabyte, then one of these math functions should be used during the bill calculation. For example, if a customer used 3.0 gigabytes, this value should be used when comparing against the amount of data purchased. However, if the customer used 3.1 gigabytes, then 4.0 gigabytes should be used when comparing against the amount of the data purchased. Which of these math functions, floor, ceiling, or round, would be best when calculating the customer's bill? When I started writing the code for the bill customers method, I saw that there was a lot of code that was repeated when processing a bill for the different plans. Only the data was different. Why keep duplicating this code over and over again? Place it in its own method and name the method compute bill. The bill customers method can collect the data for a single customer and call compute bill. When compute bill returns the bill, then bill customers can place the bill back into the accounts array. The compute bill method has all of the input data it needs for a single customer's bill. These values are passed to the method as input parameters. Used, the number of gigabytes used. Limit, the number of gigabytes purchased based on the plan. Rate, the base rate for the bill, not including any charges for being over the data limit. The compute bill method computes the bill and returns result back to the bill customers method. One of the advantages of using a separate method such as compute bill is that computing the amount of the bill is in only one place. Before this method was written, the bill was computed in 4 separate places, one for each plan. If any changes need to be made in computing the bill, they only need to be done in one place instead of 4 or more, reducing the possibility of not updating all of the code if there was a change. Another advantage is that this method can be used without modification if the program is updated to read the customer information from a disk file instead of being placed in a pre-initialized array, as is used in this program. In this section of code, the compute bill method is called using the selected values for plan A. The gigabytes parameter contains the number of gigabytes that was retrieved from the array at the top of the try block. Plan A limit and Plan A rate are constants defined at the top of the program. A series of else-if statements need to be written which call the compute bill method for Plan B, Plan C, and Plan D. The compute bill method has its own names for the parameters as the data comes in, used, limit, and rate. The method receives only numeric values into these parameters. For example, if the customer is on plan A and 2.6 gigabytes were used, then the variable used would contain 2.6. The variable limit would contain 0.0. That's what is defined as the number of gigabytes included for plan A. The variable rate would contain 50.0. That is what is defined as the base billing rate for plan A. Each of these variables are referred to as local variables and exist only while the compute bill method is being executed. The first thing that happens in compute bill is to determine if the customer used more gigabytes than was on the selected plan. Remember that the customer is charged for each gigabyte or any portion of a gigabyte. If 3.2 gigabytes were used, the customer would be billed with 4 gigabytes minus the amount included on the plan. The over-limit variable will hold the number of gigabytes over the plan. The bill is computed as the base rate plus over-limit times the over-limit charge, which is defined at the top of the program as $15. Once the bill has been computed, it is returned back to the bill each customer method. Use a for loop in the print billing method to step through the list of customers. Inside the for loop, print the billing statement using at least 2 lines for each customer with 1 place past the decimal for the data usage and 2 places past the decimal for the amount owed on the bill. The project also has a requirement to use a separate for loop to compute the total of all the customer bills. The cell phone company wants to know how much money it will be collecting during the month. There is no sample code for the total of all bills, but you can refer to the review of arrays at the top of the discussion for hints. Have fun with this project. You should learn a lot about organizing a project into separate modules and working with double-dimensional arrays. Go slowly through the code that is provided for the project and try to understand every part of the program. Enjoy and keep programming. Bye.